Hi, this is Big Al, the Renaissance man, and I'm here to talk to you about how to install a split system ductless air conditioning system from Ingram's Water and Air. I'm going to be installing it on this wall right here, and it's an interior wall, and we're going to have to find a way to get the pipes down under the porch and out to the compressor unit. So the first thing we're going to do is we're going to remove all of these panels to expose the space behind the wall. So I just got through remodeling this porch. We had some ugly vinyl windows in here that leaked and kept on blowing out in the wind. So we had all the windows in this porch replaced by insulated glass windows, glass sliding windows. We've got 50 feet running this way, and we've got another 50 feet running this way. So we've got about 1,200 square feet of porch that we need to air condition. And we're going to use a ductless unit from Ingram's Water and Air from Paducah, Kentucky. And now what everybody's been waiting for, let's start a little bit of the demolition work. We're going to try to take out this panel right here, which I think is just stapled on. I want to crack it. And I know it's stapled up. The rest of the panels ought to come out a lot easier. Now we got a lot of room back here. There's our space behind the wall, and we're going to mount the unit right up in here. I'm probably going to build a plywood platform for it to attach to the wall to bring it out flush, and then mount the unit to the plywood. So I'm going to pick up the unit. It's not real heavy. They say it's 36 pounds. I'm not sure it really is. And I've just got enough room over here to get the lines through. It's not quite according to specs. I'm about 3 inches away from where they tell you to drill the hole through the wall to put the lines in, but I don't see any problem with this. It's going to fit just fine. So we're going to just heft this baby up, and it just hangs on these brackets here, and it is now snapped in place. And that's how you hang the unit. Now I've got to fish the pipes, the line set from underneath the porch and up through a 2.5-inch hole that I've got drilled here, and the drain line, which, by the way, they don't supply the long drain line hose that'll go out. They only supply a little short hose here, so you have to supply your own drain line. So now I've got to get underneath the porch, and we'll go from there. Okay, so I'm shooting this with my cell phone camera because it's kind of drizzling and I don't want to bring my Nikon out here. But I hauled the compressor, which is about 125 pounds, with my handy hand truck and a strap and a blanket to put around the compressor so it doesn't get scratched. And I came through here and set the compressor on the plastic pad that was conveniently part of the order. Of course, I had to pay a little extra for it. It was $39, but well worth it. And we're going to be running the lines underneath the porch and over to where you see that wire coming out of the wall there. And it's about 28 feet. I've got 35 feet of pipe. And I'm going to go back over to my shop and get some strapping and something to put around the strapping so it doesn't cut into the insulation, so that I can attach it to the bottom of the joist. Well, it's late March in Florida. It's like June. It's 85 degrees. It's about 90% humidity. It's drizzling outside, and I'm hotter than heck. But all by myself, I got the lines fished in from below. We've got the suction line, the liquid line. We've got the I've got some 5/8-inch hose left over from a boat restoration project for the drain line, and I've got the armored conduit for the electric line. And I'm ready to hook everything up here, and then once I do that, I'm going to go down below and situate my lines so that they have a nice gradual slope down to the compressor so that there's no dips to trap oil in. And then I'll connect it to the compressor. This project has been a bag of worms because of where this thing is at, and because I didn't have the correct dimensions for the evaporator unit, but we deal with stuff like that. So next step is to connect. Oh, and by the way, well, I'll talk about that later. I'm going to talk about how to torque a line fitting with a torque wrench and a crow's foot to get an accurate torque reading, because it's very important on a 410A system, which runs under considerably higher pressure than an R22, to get a leak-free connection without destroying the threads. So we'll talk about that in a minute. So I've got the lines fished up, and I connected the suction line already. Put a little bit of refrigeration oil on the threads of the nut to make it torque down better. And I'm connecting the liquid line now, or the high pressure line, and I'm just getting them finger tight right now. The evaporator was under pressure. It must have had nitrogen in there. So if you pop the nuts, the temporary nuts on the evaporator, and you hear something hissing out, that's just the nitrogen in the system, the dry nitrogen, to keep it nice and clean. So I've got the lines connected. This is the drain line, and I've got a 5/8 inch rubber tube here, left over from a boat project, and I'm going to clamp that in place over here. And these lines are going to have to be insulated. I'll have to put some insulation around there to make sure that there's no possibility of any air, humid air, getting to the pipes, which would then leak down and get on the floor and make a mess. So you've got to really well insulate especially the vacuum line, because it gets really cold. And this is the electric, which I'm going to fish up through the back of the unit, and it goes up over here. And I'll connect that up, and then once I get all these connections here, I'm going to go down to the compressor unit. All in all, installing the split system is not a project for the weekender. It's kind of a complex project. There's a lot of things to remember. Evacuating the lines is going to be interesting, and I'll get into that in a little while. Fish the wire behind the unit, and since it's sticking 6 inches out, I was able to wire it after the fact. If you do this on a wall, you'll probably have to wire it ahead of time and then hang the unit with the wire already in place. But that just gives you some idea of what the connection looks like. So now I'm at the front panel of the indoor unit, and I've got the white, green, black, and red wires coming up into the unit. And if I'm using my cell phone here because it works a lot better than my Nikon, line 1, line 2 are the black and the red, and the ground, which is the third one from the left, is green, and I would assume that the one all the way on the right hand side is the white. So I'm going to connect those up now. The electrical connections are done, and this is a 220 volt system, so line 1 and line 2 are black and red. They could be both black too, but you never use a white on a 220 volt system. White is usually neutral. The green is on the ground, and the white, I believe, is the control wire that signals the compressor what to do, and vice versa. So I also am a bit of a marine electrician, so I like to use spade connectors. Makes it a lot easier to get them underneath the screw head, and just makes a nice, neat job. Got a disconnect switch here that is connected to a sub panel on a 25 amp breaker. This is just a disconnect switch, an on-off, that allows you to service the unit without having to go to a breaker. It's code that you have to have a disconnect near the unit, and the wire, the conduit, waterproof conduit goes here. And I've got the 240 volts connected to the power supply and the indoor unit connected to the indoor unit, and it's all ready to button up. And it's time to screw the compressor down to the base. And being a boat guy, I'm going to use some stainless steel lag bolts and some stainless steel washers. And I'm just going to drill a pilot hole into the base. And stainless steel is nice because it doesn't rust, it always looks good, and it's just a mark of a professional job. And anything that's exposed out into the weather, you should just use stainless steel. It's not that much more expensive. Stainless steel, contrary to popular belief, is easy to get. You can get it at McMaster.com, which is a big industrial supply house in Chicago. It just makes a nicer job. I've decided I'm going to, well, I figured out that my tubing is about 27 feet worth, so since the ends of the tubing are flared and not brazed, I'm just going to cut them off with a tubing cutter, and I'm going to do some flares on the end of the tubing, because that's something within my expertise, although I can braze, but I really don't want to, because then you have to flush the lines with nitrogen and it's a pain in the butt. So that's what I'm going to do. I'm going to cut the lines and we're going to attach over to the compressor. Cutting this tubing, and this is the end that that came from the supplier, and there's little or no flare on the end of this tubing, so it was not flared properly at all. So I'm glad I got my flaring tools, and I'm glad I cut the tubing, and we're going to do a little better job hopefully on this. Cut the main line, and I've cut the 3/8 line, and you have to be really careful that you don't get any debris, dust, anything, rainwater. You got to protect them with your life, because you get any junk inside that tube and you're going to have a problem. In fact, when you ream the tube out, you really need to pack it with something that you can pull out with a pair of needle nose or something to keep any chips of copper out of the end of the tubing, because it'll get into your capillary tube or your expansion valve, and it will stop up your system, as what happened to me when I had a system installed at a house by a licensed contractor, and apparently whoever installed it had no clue what he was doing, because I had nothing but trouble with that system. It burned out the compressor, and finally found out that there was a piece of debris in the expansion valve, and it kept on going over pressure. And once we replaced the expansion valve, everything was wonderful. So I've reamed out the end of the tube, and I've got the tube pointed at a downward angle, and then I'm tapping it to make sure that any debris is coming out. And then I'm putting the tube in the fixture, and the documentation calls for the tube to stick out the end by 1.5 millimeters. So I've got my millimeter scale here, and stick it out 1.5 millimeters. And then I'm going to use my flaring tool, and unfortunately the camera is not in a real good angle to really see what I'm doing here, but it's pretty straightforward. you just bell the end, make sure the nut's on, of course. And make a nice, not too tight. You don't want it to distort the flare, otherwise you'll get leaks. And hopefully I've done it correctly. It looks pretty good. Little rough edges. I hate that. But this is a much better flare. I don't know if you can see the difference between that flare and this flare, which is the way the supplier delivered it, which is no flare. That would have leaked, no problem. And now we're going to connect it up to the unit. Well, I guess I'll do this one next, but I think I'll connect this one to the unit just to get it out of the way and make sure we don't get any dirt in there. The Freon lines are connected but not torqued down and not purged. What we're going to do in the next procedure is to disconnect the lines at both ends and blast some nitrogen through the lines to blow out any bits and pieces that might be in there, and then connect up the lines to the evaporator and the condenser and torque down the nuts. And then we're going to do a triple evacuation, which means that we purge the lines with nitrogen. We evacuate first. We fill the lines with nitrogen to do a pressure test at about 300 psi. Shoot some soapy water around the connections to make sure everything is great. And then we evacuate, and then we fill the lines with nitrogen to about 2 or 3 psi and let them sit for an hour or two to absorb any moisture that might be in the system, and then evacuate and repeat the procedure again. And then evacuate the last time down to 500 microns or less. And once we're evacuated down to 500 microns or less, we're going to open up the service valves and the Freon will flow free and we'll fire up the unit. And I'm going to be cool because I'm really tired of being hot and sweaty because it is humid and hot here. So here I am torquing down the high pressure line on the system, and previously, when I was down at the compressor, I noticed that the flare was not correct on the high pressure line, and stupid me didn't check this end of the high pressure line, and the flare is no good from the factory either. When I tightened down the nut, it just pushed the tube right out of the nut, and I was wondering why the tube was still loose and the nut was tight. So I'm going to have to reflare this line set from the factory or from Ingram's, wherever it came from, and start over again. I've discovered that this project is not really the project for a two-car garage handyman. In order to torque down the pressure lines, or the line set, you need a 1 1/16 crowfoot wrench in order to fit the nut. Well, 1 1/16 crowfoots don't exactly exist. So fortunately I have a milling machine, and I took a 1-inch crowfoot and I milled it to 1 1/16, or I think it was 1 3/32. Anyway, that's what it takes. And in order to get the correct torque on a standard torque wrench, you can't use the crowfoot at the end like this, because that would extend your lever arm and you would actually be torquing it more than what it registers on the torque wrench. So you simply turn it at 90 degrees, and now you've got the same moment arm, and you're easily able to torque the nuts down. And of course, the proper way is to start at about 5 pounds less torque than you need. In the case of the 5/8 inch suction line, the nut required between 45 and 59 foot-pounds of torque. So I set it to 40 at the beginning, and then I used, of course, 2 wrenches, and you just torque it until the wrench clicks, and then you turn it up 5 pounds and you torque it until it clicks again, and then you turn it up another 5 pounds and torque it until it clicks. And that's how you torque down the lines. And with a high pressure system, I would strongly recommend torquing down the lines. Make sure you put a little refrigeration oil on the threads of the nut and on the flare, just to make sure that everything's lubricated, because what you're doing is you're essentially compressing the copper, deforming the copper to fit the end of the flare. That's all there is to it. But it is a little bit complicated if you don't have a milling machine and a machine shop to do this. So probably if you're installing one of these things, you probably just need to get an air conditioning contractor serviceman to do it, because this has really gotten to be a big project. I've done a soap bubble test. The system is pressurized with nitrogen up to 250 psi, and I don't see any bubbles forming other than the standard soap bubbles. And I checked the compressor as well, and there are no bubbles there. I coated it thoroughly, took a cup of water and some Dawn dishwashing detergent and put it on with a brush and looked for bubbles, and there's no bubbles. So we are leak-free under pressure, which is a great thing. I'm down at the compressor, and as you can see, I've got 1.65 millipascals, and it's holding steady. Being under pressure and checking it with soap bubbles, here's my setup. I evacuated the system first for just a couple of minutes just to get any of the air out. But since I was filling it with nitrogen, I didn't elect to deep vacuum it. And I'm going to let this set for a while and go back and leak check the connections again. I might even boost the pressure a little bit. And we'll make sure that we don't have any leaks. I've done the leak test. I pressurized the system with almost 300 psi of nitrogen. Now I'm doing the first drawdown of the triple evacuation. I bled off the high pressure nitrogen in the system down to about 2 psi. Then I connected the vacuum pump and started drawing down the system. One thing I discovered is that I was getting a leak in this valve right here that's on my Micron meter. So on my next go-round, when I pressurize the system with nitrogen again to about 2 psi, I'm going to remove that valve because it's old and cranky and I can't get a good drawdown on it. Right now it's showing about 2250 microns, which is not bad for starters. It's been running about 10 minutes, and here's my $58 eBay manifold gauge and my $119 Chinese eBay vacuum pump. Now, one thing I might mention is I'm going to, on the final vacuum drawdown, I'm going to replace the oil in the vacuum pump so I can get a 100% 500 micron or less drawdown. I don't know if it'll make it today, I mean right now on this first drawdown, but once we put more nitrogen into the system in the second and third drawdowns, it's going to hopefully absorb any moisture in the system, and we'll get a really good vacuum on the final drawdown. So on the first drawdown, with the vacuum pump off and the valves closed, of course the Micron meter is connected to the system, we've been able to draw it down to 1550 microns, which isn't too bad. We want to get below 500 on the third drawdown. So now we're going to release a little nitrogen into the system, just up to about 2 psi, to fill the lines, and then we'll evacuate again. Well, it's been about 15 or 20 minutes on the second drawdown, and the little old two-stage Chinese pump is still drawing it down. We're at 890 right now. I'm going to see if I can get down to 500 on the second draw. Oop, 880. So we'll let it run for another 15 or 20 minutes, and we're going to see what happens. The Chinese vacuum pump is getting up to about 84 degrees centigrade. That's pretty darn hot. The actual pump itself is 71. So I'm not really sure where I'm going to go with this. I don't know if I'm going to try to get it all the way down to 500 on the second drawdown. I think I may wait for the third. Alright, so I could only get it down to 700 microns. So the pump was getting hot, and I think the pump is just too hot. So, glutton for punishment that I am, I've got a 500 CFM electric blower blowing on this pump, and I'm cooling it down to room temperature. And then I'm going to start it up again. So it'll probably take about 15 or 20 minutes to cool the pump down, because it got up to about 90 degrees centigrade, which is about 170, 180 degrees. And, you know, oil gets thin and stuff doesn't work at high temperatures. So let's try this tack. I can't get it below 700 microns even with the blower on the pump. So I suspect it's the oil, because I've been playing with the pump prior to trying to evacuate the system, and it is the oil that came, the Chinese oil that came with the pump. So I've got a gallon of quality vacuum pump oil coming. It'll be here in a day or two, so I'm just going to fill the system with some nitrogen and seal it all up, and when I get some new vacuum oil, we'll try it again, because I was actually able to get this pump down to 80 microns when I was playing around with it. But I think the oil it probably needed to break in, and the oil needs to be flushed out and cleaned out, and so we'll give it a shot when we get some more vacuum pump oil. Okay, so I'm drawing it down for the third time, and this time I've removed all the rubber hoses, and I'm using direct copper so that there's no possibility of any hose permeation. And the Micron gauge is going down. It's evacuating, so we're gonna let it run and let's see what happens. Fresh oil and all metal piping seems to make the difference. It's going down below, getting into the 600s now, so let's keep on going. Let's see how low we can get it. In the shop, with the fresh oil, I was able to get it down to about 240, so let's see what happens here. Alright, I'm under 400 microns now, and it's only been about 15 minutes. And the LG docs say to go to 300 and then shut off the valve at the vacuum pump and see if it holds under 500. So we'll see what happens. I'm scared to death of this Chinese vacuum pump burning up before I finish the job, so I've got this fan on it, and I'm hoping to keep it nice and cool until we get through the job. My conclusion is, if you're going to use a Chinese vacuum pump, you're taking a chance. Okay, so we just broke 300. So I'm going to shut the valve off on the vacuum pump and turn off the pump, and let's see where it holds at. See if I'm any good at this. According to the LG docs, you're supposed to wait 5 minutes after you get it down to 300 microns to see if it holds to less than 500, and it's been about 8 minutes now, and we're still at 475, so I'm real thrilled with this. I'm gonna open up the high and low service valves and pressurize the system, and I think we're good to go. Well, as you can see, I've finished my project. This is my 24,000 BTU 20 SCER ductless air conditioning system from Ingram's Water and Air. And the project has been quite enlightening. I've got a couple of notes here. I just want to let you know that you definitely need some special tools if you're going to be doing this by yourself. You're going to need a vacuum pump that'll bring it down to at least 200 microns. You're going to need a Micron vacuum meter. You're going to need a manifold set to measure your pressures. You're going to need a nitrogen tank and a regulator. And you're going to need some considerable expertise and some tools in order to tighten up the nuts on the pipes and evacuate the system. This unit is working perfectly. I don't have it on now because the weather all of a sudden got really nice here in Florida. It was 85 and 85 degree humidity, but today it's beautiful. But this thing is whisper quiet, and I'm very satisfied. I got the unit from Ingram's Water and Air in less than 5 days. I ordered it on Monday. It came out of Tennessee, and I got it here in Florida on Friday. So it was about a 3-day project to install it. It was not the normal installation on an outside wall. It was on an interior wall, and I had to run the line set down the wall and under the floor. And then I had some remodeling to do, and now I've got my high definition TV and my Netflix and my super sound system, and now I've got a great porch, and I'm very satisfied, and I'm actually going to buy another one of these for my lake house. And I've got another porch similar to this, and glutton for punishment that I am, I'm going to install it myself again. So if you don't have all the tools cost about probably about $350 for the vacuum pump and the Micron meter and the gauge set. They're all Chinese, and I wouldn't use them professionally, but they did the job. You can use them a couple of times a year, that's fine. If you're not real handy, I would suggest just calling a refrigeration guy, an air conditioning contractor, serviceman, and have him run the line sets. You can certainly do the physical installation yourself. You can put the compressor in. You can do any remodeling, woodworking type of work, but let a professional install one of these things, because it is not trivial by any means. And if you screw it up, you're going to have to evacuate all the Freon out of the system, and then you're going to have to weigh the Freon or the 410A exactly, because these things are really critical because they're a capillary system. So get a pro. Don't be like Renaissance Al and try to do it yourself unless you really know what you're doing. Thanks for watching. Bye.